On number 10 of the fall 2012 final exam, we have three forces applied to this object, this beam, and we want to determine the net torque about point A. Specify the direction of the torque as clockwise or counterclockwise. So let's identify where we're at here. In green, here's point A. So we're going to sum the torques or moments about point A of these three forces. This 16-pound horizontal force, 14-pound vertical force, and this 8-pound force at a 50-degree angle off on the end. And we're given some dimensions as shown. I'm just going to redraw this. You would not have to redraw it, but sometimes it helps to get everything situated here. So here's A. Okay, here's some sort of offset here, and the three forces, the horizontal 16 pounds. Okay, remember that when we're doing with torques, the important thing is the perpendicular distance. So the horizontal force, we're going to use this perpendicular distance right here between the line of action of the force and the point we're summing moments about. So this 2-foot distance is the important value there. I'm going to draw that in blue. Okay. Go ahead and finish up my forces. We have this 14-pound vertical force. Okay, so vertical force, we're interested in the horizontal distance. Okay, so that is this 5 feet right here. So there's the important distance there. And lastly, I'm going to break the 8-pound force into components, because it's really easy to get perpendicular distances there. So we'll have a downward and a rightward component. Okay, this is going to be 8. If I redraw it up here, that's this part of the triangle. Alright, the 50 degrees is in here, so it's going to be sine of 50. Okay, and then this rightward is going to be 8 cosine of 50. If I go to look at the distances, this one's actually going, line of action is actually going through point A, so that will be a 0 distance. And this vertical component has the total length of the beam, which is 5 and 4. So its line of action perpendicular distance is 9. So there's our three important distances and our forces. So all that's left, so we're going to sum some torques about A. We want the net torque about point A. So let's start with 8 cosine 50. And its distance is going to be 0. And we'll do the 8 sine of 50, where I talked about its distance being 9 feet. Okay, this is going to cause a counterclockwise rotation. This component going around A would rotate in a counterclockwise, so it's going to be a positive. We'll write that separately just to be able to emphasize that, so it's going to be a positive value right there. Okay, and then let's see, we've got our, I didn't label it here, but this was the 14-pound force. Alright, so again, 14, oops, let's be consistent with our colors. So it's going to be 14 magnitude, the horizontal distance of 5. Okay, this force is going to cause a clockwise rotation about A. So we're going to use clockwise as negative. I'll probably remind myself over here, draw counterclockwise as positive. Alright, so one of the keys to this problem is consider all the forces. We have one more left. So I'll write it down here, the 16 magnitude, the 2 vertical distance. I guess I had room over here. 16. Early in the morning. 16 magnitude, distance of 2. Okay, and this will also cause a clockwise. So envision the line of action going past point A and how it rotates, okay, clockwise, so it's negative. Alright, so we just add all these up. We've got 3 forces, one broken down into components, one obviously became 0. Okay. So not adding in the 0, 1, I'll have 8 sine 50 times 9 minus 14 times 5 minus 16 times 2. Okay, so that gives me a value of minus 46.8. The units will be the force units and the distant units, so foot, pounds. Okay, a minus sign, since we took positive as counterclockwise, the minus sign means it's clockwise. So we'll write our final answer as a magnitude of 46.8 positive foot-pounds, and we'll count for the direction with the word clockwise. Just a point of note, don't put negative 46.8 clockwise, because that would imply it's the opposite of clockwise. So be consistent, either use a coordinate system in plus or minus, or use the word in just the magnitude or absolute value of the torque.